connecting to cloud server. Weird. Hopefully it's okay. Okay, should be okay. I'm just gonna check on here, make sure everything looks good. Okay, looks like we're still up and running, so that's good. Oh, okay. So there is a lot going on, or not a lot, but there are quite a few steps going on in between here. And so that's why I say, okay, as long as we're able to move from here to here, we don't actually need to memorize it, right? There's no point in memorizing this. You just need to be able to get there, right? Just like we did with this here. And then the last law is very similar, right? I have a to the negative n over b to the negative m, which is a different power, right? So I can't really use that, that rule that I can pull out the same power, right? So, but I can rewrite a to the negative n as 1 over a to the n over 1 over b to the m, and I would get the same result, right? I've got a fraction over a fraction, flip and multiply, and that's what puts me here, right? So you can try that one on your own. As a lot of textbooks like to say, we'll leave it as an exercise to the reader, and that's you. So, but the general steps that you would follow are here. Okay. You can just memorize. So Sarfraz asked if, will you ask us to prove the law, or can we just memorize it? You can just memorize it, that's fine. But I think what you'll find is that once you've done a few of these, it's just gonna go so quick that you don't need to know all those laws. But you do need to kind of memorize them. No, I will not question the steps, right? So sometimes, and as I show work, right, I'll kind of highlight what I expect to see and what's kind of extra. So I do want to see work, right? So if you're going from here straight to here, you'll have to say by the exponent laws, right? If you're skipping all these steps, you'll have to tell me what's your justification for doing that. So then you would have to say, I can go from here to here by the laws of exponents. And that's fine. Good. Awesome. Okay. So let's talk about, so exponents are pretty common in scientific notation. We're not going to deal a lot with scientific notation, but it's really important that you've seen it and are kind of aware of what it is. It might be a review, which is really nice, right? So just stay tuned. Scientific notation. Hey, I didn't even do any examples. I was checking the time, and because I just taught this whole section earlier, I was like, hey, we're really ahead of schedule because we didn't do any examples. Let me pull up the examples that I want us to do for these. Just some practice with the laws of exponents. Okay, so simplify the following. I'll start with just 3, and then if we want, we can do more. But I'm just going to write down these 3 because they're on a different screen, so I'm not on the Zoom page. W to the negative 2 times W to the negative 4 times W to the power and then y to the 7, y to the 0 over y to the 10. And then kind of bigger deal, or a little bit harder, 8a to the 3, b to the negative 4 over 2a to the negative 5, b to the power of 5. Let me just get back to the Zoom page here. Good. So we'll work through these. I'm just gonna move these up to the side here, or maybe down low. While we work through this one. So that first law says that as long as we have the same base and we're multiplying the same base, we can just add the exponents to combine them, right? And that applies for 2, 3, 4, 5 bases, as long as it's all the same base. So we've got w to the negative 2 plus negative 4 plus 5. So I like to do so I like to do plus negative, right? Because otherwise I might miss it, or I just want to make sure that I capture all my negatives because it's going to make a big difference. So now I have negative 2 plus negative 4 is negative 6 plus 5. So I get w to the negative 1. Right? But w to negative 1 is the same as 1 over w to the power of 1, but usually I don't write the power of 1, right? Power of 1 is just itself, so that's good. Nice. And then I'm going to move this, save it for later here. It's just kind of moving around. Yeah. But let's simplify this next one. Y to the power of 7 times y to the power of 0 divided by y to the power of 10. So they're all the same base still. Okay. So you have a over b to the negative 2. Could I say x to the negative and 1 over x to them? Therefore, let's see. Oh yeah. So Vaughn asked, I'll just do it in a different color over here. But yeah, if you have, and I'll scroll up a little bit. So if you have a over b to the negative 2, is that, am I reading that right? Okay, good. So then that's gonna be, if it's a over b to the negative 2, I could rewrite that as a times b to the negative 2, which is just a b squared. But the square is only on the b, right? Does that make sense? Okay. Forget this ever happened. Well, actually, I can just keep it. If you have a over b to the negative 2, brackets, right? That's going to be, I can rewrite that as a to the negative 2 over b to the negative 2, right? I'm allowed to bring it inside. And then I'm going to have 1 over a to the power of 2 over 1 over b to the power of 2, which I've got a fraction over a fraction, so I'm going to flip and multiply. So I've got 1 over a to the power of 2. Scoot this up a little bit. One over a to the power of 2 times b to the power of 2 over 1, which is just b to the power of 2 over a to the power of 2, which is b over a to the power of 2, which I think, yeah, is exactly what you said. Okay. Nice. So this one that we were working on here, there's lots of different ways. So the order that you do things will be kind of personal choice, right? And so I always like to bring everything up to the numerator unless it's really easy to kind of consolidate things separately. So you'll just have to look at them and see kind of what's going on. But y to the power of 0, you could ignore. I'm not going to, just for the sake of just an example. But y to the power of 0, anything to the power of 0 is just 1, right? So technically you have y to the power of 7 times 1 here, and then divided by y to the 10. So, right, you could ignore this one, just say it's 1 and leave it be. But what I'm going to do is I'm going to bring that y to the 10 up to the numerator by doing y to the 7 times y to the 0 times y to the negative 10. Okay. Because I've got the same base here, I'm allowed to, again, add up these exponents to consolidate them. And so I've got y to the 7 plus 0 plus negative 10. So then I've got 7 plus 0 minus 10 puts me at y to the negative 3, which is the same as 1 over y to the 3. Whichever version you prefer, if you want to write y to the negative 3, that's fine. If you want to write y to the 1 over y to the 3, that's totally fine too. All right, so it's just a matter of preference, which one you prefer, because they're equivalent. And it doesn't matter which approach you take, you should always get to the same answer. Otherwise, you've done something illegal. Now's a good time to kind of mention some good math behavior, right? So good math behavior is trying to stack your equal signs as much as possible, right? So there are situations like you just saw here, I'm trying to stack my equal signs, but then honestly, I'm so close to the end that I just put it on the end, right? And so, but as much as possible, you should try to stack your equal signs and then just kind of say, okay, I started here and then it just kind of developed as I went this way, right? So I don't want to see equal signs across the page, right? Because it gets really messy and it gets really nasty. Of course, stacking your equal signs uses up more paper, more space, but it's worth it. For being able to read your work, it's worth it. So here, I'll call it a math note, right? Try to stack your equal signs as much as possible. Try to stack your equal signs as much as possible. Yeah. Good. So how about we do this last one? It's a little bit bigger. Right? Put it on the fresh page. So like I said, there are a couple of different ways that we can deal with this. One way is to kind of separate. So I've got 8 over 2, I've got a to the 3 over a to the negative 5, right? Those are the same base. And then I've got b to the negative 4 and b to the 5. So I could lump these, right? Because I'm just multiplying and dividing, I'm allowed to do that. I'm only going to do it for the 8 over 2 to kind of deal with that separately. And I'll show you what I mean. So here, I'm going to write 8 over 2 times a to the 3 times b to the negative 4 over a to the negative 5 times b to the power of 5. Right? You'll see here that I'm just multiplying fractions, right? So I can just as easily go from here and break it up. If it's more convenient, I can break up a fraction as long as I'm multiplying, because if I multiply these back across, I get back to where I started, right? So I'm allowed to do that, and sometimes it makes it a lot easier if we do that. So I could do the same thing for the A's and the B's and separate them out, but again, for the sake of the example, I'm just going to bring everything in the denominator, so that a to the negative 5, b to the 5, I'm going to bring it upstairs to the numerator and then collect my like bases and then deal with them that way. But at least by separating out this 8 over 2, I can just reduce it to 4 right away. So this becomes 4 times a to the 3, b to the negative 4 times a to the negative 5, right? Be careful with your negatives, times b to the negative 5. Sorry, you guys are my last class of the week. Woohoo! But it also means that my voice is just completely dead, especially in the first couple of weeks of classes, because you go all summer and I don't talk for very long, or at least not like this, right? So anyways, all right, so I brought everything up to the numerator, right? So now I can only, yeah, when you just talk. So my voice will get trained as we go, so it'll be better, but you'll always be the last class of the week, unfortunately. So we want to keep in mind that we can only collect these, right? And we can only consolidate them if they have the same base. So I'm going to put my A's together and then my B's together. Hey, it's kind of lagging now. There. So I've got 4, and then I've got a to the 3 times a to the, and I'm going to just make my negative 5 just positive 5. And then I've got b to the negative 4, b to the negative 5. Because now I've got these groupings. So I've got 4. Uh-oh. Sun's coming around the corner. Earlier it was so bright, just right in my face. I couldn't see the screen. And then it's a new house, so it doesn't have any blinds yet, and it's really annoying, but it's nice to have sunshine, so I'm not complaining, but I am complaining. Aha. Okay, so I've got 4 times a to the 3 plus 5, right? I'm allowed to do that. Times b to the negative 4 plus negative 5. 4 times, and then 3 plus 5, a to the power of 8. B to the negative 4 plus negative 5 puts me at negative 9. And just to clean it up a bit, you can leave it like this. This is totally fine, unless I said with only positive exponents, right? So what we can do is we can rewrite this as 4a to the 8 over b to the 9. Either way, it's fine. In the future, right, I don't expect to see all of these steps that I'm showing here, right? In fact, you could go straight from here down to a to the 8. That's totally fine. We're working on, why is it like that? How do we get from a to the 3 over a to the -5 to be a to the 8? But if you just see it right away, then you're allowed to just go from up here to here. Totally fine. Or even if you want to jump in here, works too, right? I'm just showing you all the steps because that's what we're here for, right? So, how are we feeling? Did we want another example or keep going? First person to write in the chat what they want to do will get their way. No one. Then let's keep going. Good. Vaughn gets his way. Okie dokie. So, let's see here. What are we talking about? Oh yeah, that's where I started and I was like, hey, wait a second. Forgot to do examples. So scientific notation is just an easy way to write either very large numbers or very small numbers. And so we use scientific notation to write very large or very small numbers. So the general setup is that you have some value A. A has to be between 1 inclusive or 10, so it's easier to think of A has to be between 1 and 9, right, or up to 10. And it just takes the number portion, and then we cut off all the zeros. So whether they're zeros in front, right, meaning we have a small number, or if there's zeros behind, meaning we have a very large number, right, we chop off the zeros and we write them as 10 to the power of n instead, right? And so what that looks like, right, is say we have, so as a quick example, say I have something like 30,000. Okay. In scientific notation, what I'm doing is I'm moving the decimal, which is technically here, right, even though it's not showing. I'm moving it 1, 2, 3, 4 spaces. So 1, 2, 3, 4 spaces to get to make a 3 or a 3.0. 3 is fine. 3 is going to be this A that we've got here. Okay. So 3 is the actual value, right? And then we're just chopping off the zeros by writing it in scientific notation. So we've got 3 times 10 to the power of 4 coming from how many spaces you've moved that decimal. So this value must be greater than 1, greater than or equal to 1. Or equal to 1, but less than 10. So I usually just think kind of between 1 and 9, right? Not really accurate because you could have 9.8, right? But it's just easier to think about it, 1 and 9. That way. So for example, if I've got 0.000974, what I need to do here is I need to move this decimal. So I've got an existing decimal and I need to move it 1, 2, 3, 4. But now I need to move it in the kind of into the decimals instead of out. So so how I do that is I use a negative power. Okay. And so I've got 1, 2, 3, 4. So what this ends up looking like is 9.74 is that number between 1 and 9. Let's say it, like you see here, 9.74 is not between 1 and 9, but it's just kind of loose. 1 and 10, not including 10, is just kind of hard to say. Another way you can think about it is this value is 9. So this value can't be more than 9 because then you could move that decimal one more place. So you get 9.74 times 10 to the negative 4. Okay. If we're moving into smaller numbers. Okay. So if n is negative, right, n being the power here on 10, right, if n is negative, it means that we have a very, very small number, right? We have a small number and to write it in decimal notation, right, so going from scientific notation to decimal notation, we need to move the decimal to the left, right? So if n is a negative, or if n is negative, we have a small number. So to write, I shouldn't say so, which means, well, the words aren't coming, which means we move the decimal, yeah. Which means we move the decimal. So this decimal here is the one I'm talking about. To the left. To write in decimal form. Okay. The opposite if n is positive, right? If n is positive, then we've got a large number, which means we would have to expand it out. Okay. Let's do a little example here. What's a good one that I've had up my sleeve here? Oh yeah, let's do, so what if I've got 3.19, so just a quick example, 3.19 times 10 to the power of 5. What if you have to write that just as a number? So now 3.19 times 10 to the power of 5, what I do is I just start writing 319, right, without the decimal, and then I just write as many zeros as I would need in order to bump this to the right spot. So 319, and then in theory, right, this decimal is moving from here to, wait, it wants to do something fancy. From here to here, 1, 2, 3, 4, 5. Okay. And then I can just fill those empty slots with zeros. I find it's quite a bit easier to go and make larger numbers than smaller numbers, so you'll see. Right, so 1, 2, 3, 4, 5. What if we have 9.64 times 10 to the negative 8? So now, right, I'm taking this decimal and I'm moving it to the left 8 spaces. Okay. So what I get is, usually I just write it out here, 964, and then I'm just gonna do from here 1, 2, 3, 4, 5, 6, 7, 8. This is where the decimal moved to. Seven, 8. Which means, right, if I fill these in, go 0, 0, 0, 0, 0, 0, 0, 0. Right? We always want to have a 0 out front and then our decimal. Right? So there's 1, 2, 3, 4, 5, 6, 7 zeros. Right? It'll be 1 less than the power because I had to move from here. Good. Nice. So that's about all we'll do with scientific notation. One thing to keep in mind though is it's more about your calculator. So if you, depending on what calculator you're using, it's going to be really important that you know what scientific notation looks like on here. So on your calculator, just so that you'll know what it looks like, on your calculator, try 100 to the power of 25, just something really huge. So if I do 100 to the power of 25, and depending on your calculator, you'll probably have like a, let's see if I can see here, an x to the power of a blank value button. So I do 100 and then hit that button and it should put me up top. 25, oui. Okay. Equals. So this calculator just gives me scientific notation, right? 1 times 10 to the power of 50. Okay, so my calculator gives 1 times 10 to the power of 50. So exactly scientific notation. That's great. Okay. Others give things like 1 capital E 50. Okay. So that's an option. You just read it as 1 times 10 to the power of 50. Right? So it's just a matter of recognizing when your calculator is giving you scientific notation. Or others are, or even more cryptic, 1 space 50. So that's why I want to bring it up, because if your calculator is one of those that gives you just 1 space 50, you need to be really aware of that when you see this, and don't just think it's 150. That's not right, right? and it can be really cryptic and really kind of weird. Okay, so just know how your calculator handles it. Okay, good. So just to wrap things up, let's start talking about the roots, and then we'll continue with it next day. So let's see here, just the basics of the roots. So you've probably talked about the square root. You've heard of the square root. That's just the second root, right? And so we know, oops, we know the square root, which is just like that, but it actually implies that in the little hook, you've got a 2, right? 2 is the default square root. Okay. So now we're going to start talking about different roots, and how we indicate that is we just put the n inside the hook. This, I call this the hook. I don't know if that's proper or not. It probably is, because I don't know where I would have gotten it from, but sometimes I make up terms and I don't know. What's real? So we've got n, so the nth root, so you put that little n in the hook of a. If the nth root of a is b, we can rewrite it as b to the power of n equals a. So this isn't going to be that useful to us right now, but it will come up later. So it's just good, but I'll mention it again, of course. We'll kind of highlight that that's how roots work. But what is important, what I want to talk about is if we're using our calculator to do something like that's not the square root, right? So let's say we want to do the 14th root or the 82nd root or something weird like that. On your calculator, there's only a square root button, right? So often there's just the square root button, but that's okay. We don't need a special button. To take the nth root, oops, to take the nth root on your calculator, we use the fact that the nth root of a is the same as a to the power of 1 over n. Okay. So if I want to take the, let's say, the 14th root of 3, I should put it more in the hook there. The 14th root of 3, somewhat related, yeah, so you can't take the root of a negative number, or you can't take the square root, or you can't take an even root of a negative number. It'll give you imaginary numbers, but we're not going down that route. So for us, we're just dealing with yeah. Steer clear of imaginary numbers. But we will talk about it, and I'll talk more about it next day. But I just wanted to show you the shortcut for the any root. So then I would do 3 to the power of 1 over 14 on my calculator. And usually, like I said, there's that power button, x to the power of something. So I would have 3 to the power of, and then I want to make sure that everything, the 1 over 14 is all in the power. So 1 over 14. If you've got a calculator like this, it's really glary in here, but it should show you that it's all staying up there. If it doesn't, you'll want to put the 1 over 14 in brackets, right? And make sure that it's all in the power. But then once you do that, we get a decimal answer. So I'm going to write approximately equal to because it's a decimal, so it's not exact anymore. 1.0816334. And I think that's a pretty good place to stop for today. And then we'll keep going with our roots and our properties of roots next day. Are there any questions? No? I see no questions. Oh yeah, I think, well, I haven't posted any homework. Just that getting to know WebAssign homework that was due, but I saw everyone had done it, so that's good. I think, right? And I'll post homework for last day's section and today's section. How about? Maybe I'll make them all available. I can't remember if I have yet or not. I'll have to check. So we're going to keep going through chapter 1. Hey, there's my dog. She looks like a little Harry Potter dog. So we're going through chapter 1. I posted the fundamentals part 2. So we're just going to keep working through that. So we're still in chapter 1 for quite a long time. So have a look on WebAssign for the assignment. I'll post them now if they're not already there. I don't think they are. Anyways, it's tricky because I'm using WebAssign for 2 courses. I can't keep them straight. Okay. So, no more questions? No? Then I'll stop the recording.